To write a sinusoidal function to represent this graph, we want to identify all of the key characteristics that are in this table here. So to start out, we want to decide whether we want to use a sine or a cosine function. Now we could write a function with both sine and cosine to represent this function, but I think it's going to be easier to use cosine because if we look at our y-intercept is a minimum, meaning that this is a cosine function that has just been shifted down. Now, if the y-intercept was at the midline, it would probably be easiest to use a sine function, but we are going to use cosine here because that y-intercept is a minimum. Now we want to identify the amplitude, and the amplitude is the distance from the midline to the maximum or minimum. So if we look at our maximum value here, it's going to be where y equals 1, and the minimum is going to be where y equals -7. To find the midline, the value halfway in between 1 and -7, we are just going to add these two values together and divide it by 2. So that is going to give us -6/2 or -3. So that tells us that our midline is going to be the horizontal line, y equals -3. This is exactly halfway in between our maximum and our minimum values. So this line will look something like this, the horizontal line where y equals -3. The amplitude is the distance from the midline to the maximum or minimum. So this right here is the amplitude, and the distance between -3 and 1, or -3 and -7, is going to be 4. So our amplitude is going to be 4. That is the distance from the midline to the maximum or minimum. Now moving to the period of a sine or cosine curve is the length of one cycle of the curve. So to figure out what the period is, we are going to look at the distance from one maximum point to another maximum point. So this distance here is called our period. To find the distance, we're going to take the second point, pi/2, and we are going to subtract this other first maximum of pi/6. And so if we rewrite pi/2 as 3 pi/6, and we subtract pi/6, that's going to give us 2 pi/6, or pi/3. So the period, the distance, the length of one cycle of our curve is equal to pi/3. The next row asks us whether or not there is a horizontal reflection. And so because the y-intercept here occurs at a minimum value and our function increases after that y-intercept, that tells us that there is a horizontal reflection and our lead coefficient, our a value, is going to be negative. Another way to think about this is to think about our parent function, cosine of x. So if I sketch that function here, and we are starting at our y-axis, that function is going to start at a maximum and then go down. And so because this function starts at a minimum at our y-axis and goes up, instead of starting at a maximum and decreasing after that y-intercept, we know that this function has been reflected or flipped over the x-axis and therefore is going to have a lead coefficient that is negative. And so I'm going to write that as negative LC for lead coefficient. Okay, finally, we are asked about the frequency. The frequency is the number of cycles that occurs in 2 pi, within 2 pi. And so to find the frequency, or the b value in our function here, we are going to take 2 pi and we are going to divide 2 pi by the period. So our period is pi/3. So if we take 2 pi divided by pi/3, that is going to give us our b value, or our frequency. Another way to write 2 pi divided by pi over 3 is to multiply it by the reciprocal. So we're multiplying by 3 divided by pi. So when we solve, our pi's will cancel out, which will leave us with 6 over 1, or 6. So we know that our b value, or our frequency, is going to be 6. Now that we have all of this information, we can substitute these values into this function here, and we will have our final formula. So I'm going to erase this here, and we are going to write our final function. So we have y equals a. We know that a is equal to our amplitude, which is 4. And we also know that we are going to have a negative lead coefficient because we have a reflection across our x-axis. So our a value is going to be -4. We will then have cosine. Our b value is 6. And we don't have a horizontal transformation here, so we are just going to have 6x in parentheses because our h value is 0. And then finally, k is our midline, which is -3. So this is our final function here. This graph can be represented by the function y equals -4 cosine of 6x minus 3.